Hey guys, welcome to your very first advanced algebra and trig video. Make sure you take notes on it as much as you need to. We'll look at those tomorrow, and hopefully it's pretty short. And remember, we will go over the stuff in class tomorrow also, but just good introduction and good time to get your notes taken. So stop anytime you need to and write down anything you need to. And here we go. Real number system today, the real number system. You should have heard most of the stuff before. All these numbers we're dealing with today are real numbers. Everything is a real number except for imaginary numbers. That's what I call imaginary, and we'll get to those later. But today and early, just talking about real numbers. Real numbers are broken down into two main categories, the first of which is rational. Rational is any number that you can write as a fraction, and most numbers you can write as fractions, so that is most numbers. I think that's most of the real numbers probably fall right in there. Any decimal that either stops or repeats is rational, like 0.21. You could write that as a fraction. 3.567, because it terminates or stops, you can write that as a fraction, so it is rational. Irrational numbers, the most famous one is this one right here. It's pi. 3.14158. It just keeps on going forever and ever, never stops, never repeats. The second most famous one is e. The other type that people forget about are square roots that you cannot take, like square root of 10, square root of 2, numbers that you do not know the square root of. Their square roots are irrational. This one right here gets people too. You got to be careful. It says 0.1010010000. There's a pattern, but it doesn't, it's not a repeating decimal. The same exact pattern does not repeat, so it's irrational. Integers is a subcategory of rational, and integers are everything except for fractions and decimals. Even though you see a fraction right here, negative 10/5, the negative 10/5, you could obviously make that negative 2. Negative numbers are also integers. Integers are basically negative and positive whole numbers, which brings me to the next category, which is whole numbers. Whole numbers, I'm glad they put a 0 right here. 0 is the smallest whole number. 4/2 is a whole number because it is actually 2. The square root of 9 is a whole number because it is 3. 7.00, whole number because it's really 7. No fractions, no decimals, and must be positive or 0. And the last set's natural. Natural numbers are just the numbers you count by. Like you count, you go 1, 2, 3, 4. You don't start counting by going 0, 1, 2, 3. You can't start at 1. So natural numbers are counting numbers. Make sure you have which numbers are which category. The first part of your assignment tomorrow is going to be putting numbers in the right category. All right, the second thing, and really the last thing, is called interval notation. We're really concentrating on this right here, how to write graphs into intervals. And two words here, one are called open and closed. Open is when it includes a number. Closed is when it does not include a number. For example, this right here says x is between a and b. So what they did is they drew a graph over here with a and b. Now we're going to do it this way. Instead of putting the little parentheses, we'll probably put a little empty circle. And then what that illustrates is that a and b is not included, but the included interval is right there. And the way we write that interval notation is we write a and b in parentheses. Parentheses means the numbers aren't included. If it's closed with brackets, that means there's an equal sign, and it's a filled-in circle. Filled-in circle, because it includes the a and the b. Half open is if one of them is open and one's closed, like that one will be there. And if you look at here, we have one bracket for the closed part, the inclusive part, and one parentheses for the part that is not included. Half open, again, the other way, same deal, empty, filled in, shade in between. It includes the b, it does not include the a. Open with one number, this a right here, since it's open, there's no equal sign, circle, it goes all the way to the right, keeps on going forever, so that's how we write that. We write interval from a to infinity. Anytime you put infinity, it's going to be open because technically you can't get there. You can't technically include infinity. Same thing with this one. Open going to the left. Empty circle goes to the left. I skipped one. Half open. This should actually say half closed because it does include. That's a mistake in the book. I need to write them about that. It goes forever that way. And then half open, going the other way. So, and again, I should say half closed. Another mistake. Oh, wow. This crazy book. I don't know that already. So, that's all your cases. And so the next slide, which is the last slide, we're going to show what you're going to do with these tomorrow in class. It says write interval notation for each set and graph. So 2 steps. Part A, interval notation, first of all, would be -4 to 5. And notice I've tried to make parentheses. Parentheses around both of those because there's no equals. When you draw your number line, it is your number line. You put the -4 and the 5 where you want. Just make sure the 5 is to the right of the -4. And because it's open, be empty circles and with shade in between. Part B, it just has one number. It's greater than 1.7 and it's equal to, so because it's equal to, I'm going to put a bracket, 1.7. It goes forever. Everything greater than 1.7. Draw my number line here. This time I'm just going to need one number on it, the 1.7. I'm going to put a full filled in circle because it includes the 1.7. Everything to the right. Part C, we'll stop at part C here. Actually, we'll do both. Part C, it's half open, half closed. It goes from -5. It does not include -5. It goes to -2. It does include -2 because it does have an equal sign. Draw your number line. Going from -5 to -2. -5 would have an empty circle because it's not included. The -2 would have a filled in circle, shade in between. And the last one, I guess I want to do that because it's got a square root in it. No big deal though. It's open to the left, so it's going less than square root of 5. So all the way to the left is -infinity. Square root of 5 is not included, so it's a parentheses. Draw your number line. All you have is one number, square root of 5. It's not included, so empty circle, and I'm going shading to the -infinity, shading that way. All right, that's it for the day, for this first video. Make sure you have some good notes down. See you in class tomorrow. Go over this stuff, and hope it makes sense to you. So see you then.